Here's a step-by-step that walks through each major section of the must-know network protocol dependencies diagram. Let's explore the key dependencies among common network protocols, starting from the IP layer down to individual applications. The IP layer. At the heart of every network stack, you'll find IPv4 and IPv6. Every transport or application-level protocol depends on one or both of these Internet Protocol versions. To build on IPv4, many protocols simply inherit it directly. On the IPv6 side, you have ICMPv6, an IPv6-specific version of ICMP for ping traceroute and diagnostic functions. Standard ICMP, the ping protocol, rides atop IPv4. In addition, several specialized advanced protocols also sit directly on top of IP: SCTP, Stream Control Transmission Protocol, and DCCP, Datagram Congestion Control Protocol, are alternative transport protocols that can replace or augment TCP or UDP in certain scenarios. IPsec is a set of encryption and authentication extensions that plug directly into IP, securing traffic at the network layer. The transport layer, TCP versus UDP. Once you've picked either IPv4 or IPv6, wrapped perhaps with IPsec, you choose a transport protocol. TCP, Transmission Control Protocol, provides reliable, ordered delivery. UDP, User Datagram Protocol, offers simpler, connectionless delivery without guarantees. Each of those two transports gives rise to a suite of application protocols that depend on their particular features. TCP-based applications. All of these services depend on TCP's reliability and connection-oriented behavior. You'll see them grouped together in the left-dashed box underneath TCP, HTTP, the foundation of the web, and all secure variants like HTTPS, which layer on SSL, TLS, SMTP for email, and its secure flavor SMTPS, SMTP over TLS. IMAP for mail retrieval, both plain IMAP and IMAPs, IMAP over SSL, TLS. POP3 for simple mail access, both plain POP3 and POPs, POP3 over SSL, TLS. SSH for secure remote login, RDP and VNC for GUI-based remote desktop sessions. LDAP, Lightweight Directory Access Protocol, and its encrypted form, LDAPS, LDAP over SSL, TLS. BGP, Border Gateway Protocol, for interdomain routing. SIP, Session Initiation Protocol, for initiating VoIP and video calls. POP, Post Office Protocol v3, underlies simple mail downloads. Again, when encrypted, you'll see it arrow to POPs. Notice how many of these plain protocols, HTTP, IMAP, LDAP, etc., then point to a separate SSL, TLS box. That indicates the upgrade path to a secure version: HTTP, HTTPS IMAP, IMAPs, POP3, POPs, SMTP, SMTPS, LDAP, LDAPs. Each secure variant simply rides TCP but is wrapped inside TLS-4. UDP-based applications. UDP's low latency. Connectionless nature makes it ideal for time-sensitive or broadcast-style applications, as shown in the right-dashed box underneath UDP. DNS queries and responses, the domain name system, use UDP by default for quick lookups. DHCP, Dynamic Host Configuration Protocol, for assigning IP addresses relies on UDP broadcasts. RTP, Real-Time Transport Protocol, for media streaming and VoIP, is built on UDP to minimize delays. NTP, Network Time Protocol, synchronizes clocks. Over UDP. RIP, Routing Information Protocol, uses UDP to share routing updates. Finally, QUIC sits on top of UDP. QUIC is Google's modern transport protocol that provides the reliability of TCP plus built-in encryption, so you'll see QUIC pointing to UDP beneath it. LDAP, BGP, SIP, and others. You may notice LDAP, BGP, and SIP straddling the middle area between TCP and UDP. That's because LDAP and BGP are TCP-centric protocols. They need reliable sessions. But their secure versions, LDAPS, require both TCP plus TLS. SIP can use both UDP and TCP. By default, SIP messages often start on UDP for lower overhead but can fall back to TCP if reliability is needed. Putting it all together. To recap, start at the IP layer, IPv4 or IPv6. If you need reliability and ordering, choose TCP. If you need low overhead or multicast broadcast support, choose UDP. On top of TCP, you'll find the majority of traditional services: web servers, HTTP, HTTPS, mail, SMTP, SMTPS, IMAP, IMAPs, POP3, POPs, remote access, SSH, RDP, VNC, directory, LDAP, LDAPS, routing, BGP, and session control, SIP. On top of UDP, you find time-sensitive and broadcast services like DNS, DHCP, RTP, NTP, RIP, and newer transports like QUIC. Remember, whenever you see a plain text protocol, HTTP, IMAP, SMTP, LDAP, you can arrow it to its secure TLS-wrapped sibling, HTTPS, IMAPs, SMTPS, LDAPS, via the SSL TLS box. Understanding these dependencies, IP, TCP, UDP, application protocols, plus TLS, is critical for network engineers, developers, and security professionals alike. Whenever you pick a protocol, you know exactly which lower layers it relies upon and which secure variants are available. That's your quick guide to must-know network protocol dependencies.